Hello everyone, I apologize for what happened with the previous video where we covered section 5.6 factoring. For some reasons, if you see, we start instead of starting from the beginning at section 5.6 where we talk about factoring trinomials, we're gonna just continue where with the properties, like the different steps to follow to to factor trinomials in the form in the form ax squared plus bx plus c, where a is not equal to 0 or a is not equal to 1. So first of all, you need to write all pairs of factors of ax squared, write all pairs of factors of c, the constant term, try various combination of these factors until the correct middle terms b X is found. If no combination exists, then you know the polynomial is prime. We went over already a few examples like this one. First of all is the first term. We write all pairs of factors for ax squared, which is 21x squared. We said it's going to be either x times 21x, or you can have 3x times 7x, but it can also be negative. It all depends on what we're looking for. The same way, if we have 10, now we said write all pairs of factors of c term, the constant term. So 10 can be 1 times 10 or 2 times 5. But remember, because the term in the middle is negative, this term right here is negative. So what we want to do is make sure the two numbers we're going to use for C, which is 10, we take the two negative numbers, either negative 1 times 10 or negative 2 times 5. But if you do some trial and error, let's try 3x and 7x. Remember our goal, 3 times 7 is 21. So how about 10? I'm putting 5 here and 2 here with negative because we want to show that this product right here that gives you negative 35, if you add it to that product, negative 6x, is give you the term in the middle. If that's happened, then you can conclude your factors would be 3x minus 5 times 7x minus 2. That's how you need to factor that trinomials. Next, we have, if you have 3x squared, the only way you can write 3x squared is 3x times x, right? Because 3 is prime. And 6 can be written either 2 times 3 or 1 times 6. Now, let's see if you do 3x times x, give you 3x. So how can we write 6 in order to obtain negative 7 in the middle? So what I would do here, we know for 6 we would need to use two negative numbers to obtain a positive 6. And because when we add, we're going to obtain a negative. Here we have negative, so we're going to use negative. What negative would work better for us here? Because looking at this one is going to be something not easy, right? Let's see how we're gonna do it. Okay, what are two numbers when negative 6 can be negative 3 times negative 2? Oh, look at that, because both of them negative, we're gonna have negative 2, negative 9 give you negative 11. That's not what we're looking for. Okay, we're not looking for this one. Oops. Okay, so we're not looking for this one. Now, if we erase this, oh, sorry, I'm hoping the same thing doesn't happen to me. If we erase this, if we put 3 here and 3 is going to give negative 9. So because anything you try here The only possible factor for 3x squared is 3 times 1 or 1 times 3, and the only factors for 6 is 1 times 6 or 2 times 3, but both of them must be negative. We need to medically try each pair of factors until we find a combination that works. But unfortunately, by looking, nothing works. The problem, because we have exhausted all the possible choice for the factors, but have not found a pair where the sum of the products of the outside terms and the inside terms is -7, we can conclude that this expression right here is prime and cannot be factored. Not all the time you have something that can be factored. We have some other techniques we can use. For example, here, look at that. We're looking for, let's say 6x squared y squared. We know that could be 2x. I mean, how can we rewrite 6x squared y squared? First of all, oh no. Look at that. I don't need to do this. Always pay attention to the GCF. I see 6, 2, and 60. What's the common factor? 6, 2, and 60. Yes, 2. Now, we see x squared, y squared, xy squared, y squared. What's the common factor here? Yes, y squared is the common factor. So if we get out 2y squared, we have 3x squared left here. And -2x minus, no, -x because the 2 is out, right? -2x minus 30 is this one, right? Now we have the only possible factors, now what we do here. All right. We have 3x squared. So the only possible factor for 3x squared, because if we try to factor 3x squared minus 2x minus 30, the only possible factor for 3x squared would be 3x times x. And but for 30, you have plenty, right? We have plenty. So for us, we know 2y squared times 3x times x is our factors. But now, the inside and the outside, let's try it. We're going to have 30. How to rewrite -30? Two factors, okay? And we want, when we multiply these two numbers, all right, let's see, 30. If we do 10, let's do 10 and 6. If we do 10 here, 10, 3, and make 10 negative, we see we're going to have -1. That's exactly what we're going to have. So I don't know why I put 2 again. We have no 2. Okay, because we factor 2 out. So this is the best we can do with -30. -10 and 2. So we saw -10 and +3. When you multiply these two, it gives you -30. But remember what we said about the pair rule. The sum of the products of the outside, I mean the sum of the product of the outside, like 9x, plus the sum of the product of the inside, -10x, give you bx, -x, right? So that's why we conclude this is what we're gonna have. Now, our factors is 2y squared. I just rewrite it, but we have the answer already, x plus 3. Okay, yeah, that's beautiful. That's really giantly beautiful. And we can conclude that our final answer when we ask to factor 6x squared y squared minus 2xy squared minus 60 y squared will be 2y squared times 3x minus 10 times x plus 3 would be the correct answer. Now, we can also do it by grouping. Factor out a greatest common factor if there is one other term than one. For the result trinomial ax squared plus bx plus c, find two numbers whose product is a times c and whose sum is b. Write the middle terms bx using the factors found in b. Factor out. So this is what we're gonna do. I'm gonna try to go with an examples with you. We call this AC method. Remember the trinomials in there from ax squared plus bx plus c. When you look at these trinomials, what is a? It's a equal 8, b is negative 14, and c is 5. AC method, that means multiply these two numbers. When we take AC, that means 8 times 5 is 40. Okay? Now, find two numbers. When you multiply these two numbers, it gives you 40. But when you add these two numbers, it gives you the term in the middle, which is negative 14. Okay? Two numbers, when you multiply them, it gives you positive 40. When you add them, it gives you negative 14. You know that? Remember, 1 times 40, but some doesn't give you negative 14. 2 times 20, some doesn't give you negative 14. 4 times 10. Oh, yes, I got it. So negative 4 times negative 10, negative 4 plus negative 10. Those are the two numbers. Now, that's the first step. The first step is to multiply A with C. Now, two numbers when you multiply give you A. C. When you add give you B. What we're going to do, remember, we have negative 14x in the middle. You can substitute negative 14x for, uh, you know, 4x minus 10x. That's what we're going to do here with this one. We would rewrite it 8x squared minus 4x minus 10x. Remember, this one right here gives us negative 14x plus 5. Okay? So that's what happened, you know. And now, with these two, we have 8x squared minus 4x. Okay? And we have plus negative 10x plus 5. Okay? Okay. Now, let's go. What is the common factor between, because we did factoring by grouping. If for some reason you don't have any clue about what we're talking about here, I strongly advise you to watch the previous video. I mean, on section 5.5, because on 5.5 we covered factoring by grouping. If you have 4 terms, you group them by 2 in the parentheses and make sure these 2 terms in the parentheses have a common factor. 4x squared, 8x squared, 4x, we know common factor is 4x. Now what we have left, we have 2x left, that means 8x, and we have only 1 left. Here, we can factor negative 5 to make sure that we only have 2x left, because negative 5 times 2x gives you negative 10x minus 1. Now, as you can see, we have common factor here is 2x minus 1 factor 4x minus 5. Well, actually, the first thing I did was to double check if there wasn't any common factor, the GCF between 8, 14, and 5. So there was nothing. That's why I go that way, and we conclude with these examples as is. Actually, I hope you enjoy these little examples, because uh, it's beautiful. Okay, we can even try uh, some different ones. Okay, We can even try some different ones because 2x minus 1 for x minus. Let's try a few other ones. Like here, again, AC. A, B, and C. Remember, A is 6, B is -2, C is -20. If you do 6 times -20, it gives you 6 times 2 is 12, -120. Two numbers when you multiply give you -120, but when you add these two numbers, it gives you only -2. Yay! It's -12 and 10, right? -12 plus 10 give you -2. Now what you can do, rewrite 6x squared. Now, instead of having -2x, the -2x become -12x plus 10x. So I can substitute -2x in our expressions for -12x plus 10x minus 20 the last term. Group 6x squared minus 12x plus 10x minus 20. Common factor from the first parenthesis is 6x. So we have x minus 2, 10 outside, x minus 2. So x minus 2 times 6x plus 10. Oh, I could even factor 2 at the beginning. But you know what? How about I factor it from this one? If I have 6x plus 10, you agree that 2 is the common factor. So I have 3x plus 5. So I can rewrite it, put the 2 outside, x minus 2 times 3x plus 5 would be the exact same answer. I know I go a little bit faster, so feel free to review and do it multiple times in order to not to miss this one. 2 times x minus 2 times 3x plus 5 is the one. Now, factoring by grouping, they ask us to factor by grouping. No common factor between 2, 9, and 4, but we know AC would be 2 times 4. That gives us 8. What are two numbers? When you multiply, give you 8, but when you add, give you B, which is 9. Hmm, can you see it? Because A, B, and C. Yeah, 1 times 8. 1 plus 8. So you can rewrite this one as 2x squared. Now instead of writing 9x, we're going to write x plus 8x. That make it 9x plus 4. Right? Factor any two you want. You know what? I'm going to factor, um, let's factor the first two. 2x squared plus x plus 8x plus 4. Not really factor, combining. So I can factor only x from the first parenthesis. Remember, always take things that you can at least factor some, okay? Plus 4 is a common factor. I have 2x plus 1. Remember, when you pull out the GCF, you need to make sure the two remaining factors are the same so you can factor out 2x plus 1 times x plus 4. Hey, I think we did so many, but you know what? We have some other ones to do. Here, the AC methods again is 8 times -3 give you -24. Okay, so with -24, two numbers when you multiply give you 20, -24. When you add these two numbers, it give you 10. Thank you. Is -2 times 12. -2 plus 12. Now we can rewrite this one as 8x plus, no, minus 2x plus 12x. Remember, -2x plus 12x is positive 10x minus 3. Now let's factor any two. You know you cannot put 2x with -3 because there's nothing in common. So what I'm gonna do, I would, oh, x squared, sorry. So I cannot put this on with -2. So what I would do, I can eventually put 8x squared with negative 2x and put 12x with negative 2 because remember this one we're going to have 2x factor. So we have 4x minus 1. And here, if we pull 3, we have 4x minus 1. So 4x minus 1 is the common factor. We have 2x plus 3 left. Hopefully, I know I go a little bit fast on these. It's because it's more than one example. So I just want to make sure I do enough examples for you to review. Now, to complete the factoring by grouping, we want to go very quick on something probably you saw before. It's factor by substitutions. That's a complicated polynomials you can do. Some complicated polynomials can be rewritten into a form that is easier to factor by using substitution. We replace a portion of the polynomials with a single variable, so fully now creating a format that is familiar to us for factoring. For example, here, look, I have, yeah, that's a complicated one, right? But I don't want to put all of this because for me, if I let 4r plus 1 be x, for example, it's like the whole thing here is x. The whole thing here is x, right? So meaning I have 4x squared. No, not 4x squared because it's the whole thing. Is x squared plus 8x plus 16. Now let's see. Two numbers when you multiply because there is no number greater than 1 or less than 1 in front of x, where we know we're going to do two numbers. When you multiply, give you 16. When you add, give you 8. What are these two numbers? Yes, 4 and 4. 4 times 4 give you 16. 4 plus 4 give you this. Now, we're not done. Remember, 4 times 4, that's like for us, it's like x plus 4 power 2. Now, what happened? We didn't have x. What x represent? Yes, x, remember x is 4r plus 1. All you need to do, substitute. You're going to have 4r plus 1 plus 4 power 2. So it gives you 4r plus 5 power 2 as the final answer. I tried to do one example of this one, but you have the book. Remember, the most beautiful book for algebra you're using right now is Intermediate Algebra by Ellen Martingale, 8th edition. So don't feel free to either use your e-version of that book, the e-book, or the hard copy you have. Have fun, take care. I'll see you in a different video for section 7 in chapter 5, factoring by special product. Take care.